You can use lesions or ablations. Okay, and what are those going to be?
Invasive methods used to study changes in motor control when a neural structure is removed and or lesioned.
Right. So lesion are going to be, we're going to go in there and damage some part of the central nervous system. Okay, I'm going to use poison, and we're going to go with the laser, wipe out some part, normally the brain. Okay? So that's going to be a lesion. The tissue will still be there, but I'm going to essentially damage it so it can't work. Ablation, I'm going to go in and whack the thing off. I'm going to go into the little cat, and I'm going to cut its cerebellum right off. Okay, or I'm going to go in and suck out some, nuclei inside the brain. So that's technically a difference between those two. The effect is the same. The animal can't use that part of their brain to process information and produce motion. Okay, so what is the logic that is associated with lesions and ablations? Why would I do that to an animal? Right, but try to explain the logic to me. So I have an intact animal. Its nervous system, its body is, I haven't done anything to it. It performs some action. Okay, it reaches out and, bats a ball or something. So then I'm going to go in and lesion some part of its brain. So that'll be the next step in the experiment. I'm going to remove or make sure that part of the brain can't work anymore. Now what do I do as an experimenter?
Put the ball in front of him, see if he does.
Right. So now I'm going to ask him to I'm going to ask the animal to perform the same behavior again. Thank you. Why don't you start that sheet? So the attendance sheet is coming around, so make sure you sign it. So I'm going to put that ball in front of him again, and then what am I look to see? Right. You're looking to see if the animal can either perform the action or perform in the same way. So I'm determining what capabilities I still have intact. Okay, so that's the logic of that. And let's say I remove a part of the brain and the animal performs the same movement before I remove that part of the brain. How do I interpret that?
That wasn't a part of the brain that controlled that movement?
Right, so that part of the brain didn't have a role in that particular movement. So now what if I remove part of the brain and the animal can't do that movement? I interpret that as how? How do I interpret that? Right, so now, so that part, if I remove part of the brain that can't do the movement, then I say, well, that part of the brain must have had a large role in that movement. Okay, either directly controlled or had some strong influence such that they no longer can do it. And so what experimenters used to do is go around and literally whack out certain parts of the brain to see what behaviors were left. It's called reductionism, where you reduce the system. Okay, and then you see what behaviors are there, and the logic is, well, if I can't do that behavior with that part of the brain, then that part of the brain must be important for that behavior. Okay, so that's where the whole concept of lesions and ablations come from. I mean, that's the underlying logic to it.